here. So we're asked to do an evaluate of f of a4. We're given a function here. And we're also asked to find some second derivatives. Of course, before we can find second derivatives, we have to find the first derivative. But let's go ahead with this first one, f of a4. So a is just a evaluate, plug in the point. So all we do is everywhere we see an x, we're going to put the letter a. Everywhere we see a y, we're going to put 4. So we've got x squared, so that becomes a squared times 4, plugging in for y, 3 times 4, plugging in for y, not equals, we get a plus, x squared, so that's going to be a squared, 4 cubed, minus 4 times a. And then we just kind of clean up. Usually put the numbers in front, so we'll list this as 4a squared. 3 times 4 is 12. 4 to the third is going to be 64. A squared minus 4a. And then a squared has a like term, so 4 plus 64 gives us 68 a squared minus 4a plus 12. So that's our answer to this one. Let's go with the B part. Oh, we can't quite do the B part first. Let's reset. Okay. Oops. What happened here? Took me all the way to the beginning. Okay, so come back here. So the way we'll do this, let me change here, is to, before we can get the second derivative, we have to take the first derivative. So let's take the first derivative with respect to x. That's going to give us, and again you can put it with xy, that's going to give us 2x times y. Y is a constant, it tags along, right? So we took the derivative of x squared. 3y, that's y is a constant, so this becomes 0. The second term is 0. Third term, we've got x squared y to the third. So that's going to become plus 2x y to the third. Y is a constant, right? And then the last one, minus 4x. Derivative of x is 1, so that gives us a minus 4. While I'm at it, I'm going to go ahead and take the derivative of y. Why not change colors? So the partial with respect to y, so I come to the first term. The derivative of y is 1. And I've got the x squared just tagging along for the ride, right? 1 x squared. Derivative of 3y, that's where we're at right now. Derivative of 3y is 3. Third term, x squared times y to the third. Derivative of y to the third is going to be 3y squared. And the x squared just tags along because it's a constant. And then the last term, the fourth one, minus 4x, that's x is a constant, so the derivative is 0. So these are our first derivatives. Each first derivative has 2 second derivatives. So I'll show that this is the next level. So I'm going to take this partial with respect to x, and I'm going to take its derivative with respect to x. So I don't go back to the original, I come to this one. This is what I'm going to take the derivative of. 2xy, I've taken the derivative with respect to x. Derivative of x is 1, so 2y. Those are both constants, right? But I took the derivative of x. Next one, I take the derivative of x, and I'm going to get derivative of x is 1. I get 2y to the third. And then I take the derivative of minus 4, that's a constant, so that derivative is 0. While I'm still here, let me take the derivative of the partial of x, partial with respect to x, with respect to y. So that's the other second derivative. So this is the order I'm referring back up here. 2xy, remember y is the variable of consideration right now. Derivative of y is 1, so what's left is 2x. The second term, I've got 2xy to the third. I'm taking the derivative of y. Derivative of y to the third. 3 comes down, so 2 times 3 is 6. X y squared minus 1 from the exponent. Derivative of 4 is 0. So those are the two. So these are the answers for, let's see, this is B and this is C. Now we'll do D. We'll switch colors. So we're going to take the derivative of y, the first derivative of y, and we're going to take the second derivative with respect to y. So y. Derivative of x squared is 0 because x is a constant, that's gone. Derivative of 3 is 0 because it's a constant, that's gone. So all that we get is a derivative of y squared. The 2 comes down, 2 times 3 is 6. X squared, subtract 1, we get y to the first power. That's the second derivative with respect to y. And then finally E, we're going to take the derivative with respect to y, the first derivative there, and then we're going to take it with respect to x. So we come back up here, and now we're taking the derivative of x. So x squared is going to become 2x. Derivative of 3 is 0 because that's a constant. And then I have this last part. I'm going to take the derivative with respect to x squared. The 2 comes down, so that gives me a 6. 2 minus 1 is x to the first power, and then the y squared is a constant, so it just tags along for the ride. And what you see is that C and E are identical, the same. They're equal. And this will always occur. So it's a good way to take the derivatives, and you'll see that those parts are always the same. So that is question number 8.